Welcome, and thank you for joining our webinar today. I'm your moderator, Chris Weigel from Omnitech International. We really appreciate you spending your lunchtime with us. If you have any questions or comments, we ask them that you please type them into the Q&A box or the chat box. And then after Rick's presentation, we'll get to as many questions as time allows, or we will reply back to you after the webinar. Now, at this time, I'm pleased to introduce our speaker today, Rick Heggs, Director of Business Development at Omnitech International. Rick has over 40 years experience in the materials and polymer industry, including 5 years at Omnitech, 5 as an independent consultant, and 29 years at Patel Memorial Institute. He also has extensive experience in materials processing with a focus in both thermoplastic and thermoset polymers, rubber, plus bioplastics. Rick has been named inventor on 8 U.S. patents and has numerous publications, including 2 book chapters on silane coupling agents and industrial uses of high oleic oils. Now it is my pleasure to turn it over to Rick, who will present the USB-sponsored research demonstrating the scientific evidence behind rodent attraction to soybean oil process oils. The result of this study will allow industry to move forward with the use of soy-based raw materials with confidence. Rick?
Thank you, Chris. Thank you for that great introduction. And welcome everyone for joining us today. So as Chris noted, the title of the talk is The Preference Study for Rodent Gnawing of Elastomeric or Rubber Compounds. The study background, or why we actually initiated this study, was there's a lot of anecdotal accounts on social media of individuals, people having damage to their automobiles by rodents chewing through the wires, causing, in some cases, thousands of dollars of damage. And in fact, several lawsuits have been filed against the vehicle original equipment manufacturers. I've listed 6 of them here. That list was current as of about a year ago. There may be more at this time. But all of these cases, their major claim was that soy-containing polymers and elastomers attracted rodents because there was food content or some type of soybean derivative in the rubber compound. I should note that all of these lawsuits have been dismissed, and some of them have been voluntarily withdrawn. The reason that they were dismissed is that no one could prove that these materials were attractants to rodents, and rodents, in fact, gnaw. That's part of their natural state. They, in fact, have to gnaw on things to maintain their teeth being worn down, so they don't grow through their jaws and actually could result in death for the rodent. So rodent gnawing of wiring is well known and has been known for many years prior to the introduction of soy processing oils and other materials in these rubbers and elastomers. So we wanted to go forward and put some science around these anecdotal accounts and whether it was really true or not that the addition of a soy-based material increased the attraction or gave a preference to the rodents gnawing on these materials. So as I said, we searched the literature. There was no scientific study that had been run in the literature to test the hypothesis that soy-based materials were an attractant for rodent damage. And so we designed this experiment, this test, to test that hypothesis in a controlled laboratory environment with elastomeric samples that both contained and didn't contain soil components, which were presented to mice as the rodent species. As far as the materials that we used in this study, we selected a number of elastomers. These elastomers are used in automotive production, and so the 4 different elastomer types that were studied was natural rubber or NR, styrene butadiene rubber, SBR, ethylene propylene diene monomer, EPDM, and flexible polyvinyl chloride. So I realize polyvinyl chloride is not really a rubber, it's a thermoplastic elastomer, but we included it because it's very commonly used for wire coatings, and also because it's one of the main materials where soybean oil derivatives are used as incorporated in them. So we wanted to look at different soybean oil varieties and derivatives, which are commonly used in industry in these materials. So the first material was simply degummed soybean oil, SBO. Another variant of soybean oil, which has a high oleic content, or high oleic soybean oil, HOSO, epoxidized soybean oil, or ESO, and styrene grafted soybean oil. This is an experimental compound that's being looked at by some of the industrial users as a replacement for some of the processing oils in rubber. So considering those 4 elastomers and the materials that were going into them, we developed 12 formulations. So 4 were natural rubber, 1 was the control, which contained 10% naphthenic oil, and then we replaced the naphthenic oil with either soybean oil, degummed soybean oil, high oleic soybean oil, or soybean oil that had been grafted with styrene. In the case of styrene butadiene rubber, we also had 4 compounds: the control with naphthenic oil, and replacing the naphthenic oil with the prior 3 materials derived from soybean oil. EPDM, it's not possible to replace all of the paraffinic oil with soybean oil because it's simply not that compatible. So the control had 70 pHr, so that's percent 100 parts rubber. So that's, those of you that are familiar with rubber compounding and formulations, you'll recognize that. It's not quite percentage, but it's close to a percentage. And then we replaced 20% of that paraffinic oil, which resulted in 14 pHr of high oleic, and then 56 pHr of the paraffinic oil. So 1 control and 1 test material. And then with PVC, similarly, it's not possible to replace all the phthalate plasticizer with just epoxidized soybean oil. So we replaced 20% of it, as we did in the PDM. So we had a 50 pHr phthalate formulation and replacing 20% of that phthalate formulation with 10 pHr of epoxidized soybean oil. So epoxidized soybean oil is actually sort of considered to be a secondary plasticizer in conjunction with a phthalate, because again, you can't replace all the phthalate, but it adds some processability and some heat stability to the resin, and that's why it's been used so widely. So those are the 12 formulations we studied. The study design, we wanted it to be blind. So we took the formulation in each of the 12 formulations, and we assigned a random letter value. So that was blind to the laboratory, which was going to be conducting the rodent study. We made 10 plaques of each formulation, so 120 plaques in total, and they were exposed to a male CD1 clone mouse in an individual container for 14 days. This is a picture of the container along with the specimen, the black square, the rubber specimen, and the mouse, which was in the cage or in the container, had access to the plaque completely. So to evaluate the damage, 2 metrics were used. It's just a simple loss of weight, so the weight of the original plaque on day 0, and then the weight of the plaque on day X. So we looked at them at both day 8 and at day 15. And then gnawing damage was a more subjective evaluation. We wanted to look at the area of the plaque which was affected. So we had a 1 to 4 scale, 1 being 0 to 25% affected, 2, 25 to 50, 3, 50 to 75, and 4, 75 to 100% of the plaque area being affected. And as I noted, these tests were measured, these metrics were measured on day 8 and day 15. I wanted to show you an example of a damage that we were seeing in some of the plaques. This is the PVC control. It had no soy material in it, just 50 PHR of phthalate. And as you can see, this is a fairly, excuse me, going back. As you can see, the mouse had gnawed around the edges and had created quite a bit of damage to the PVC plaque. So if you wanted to look at an example of no damage, this is the EPDM rubber that had 20% of the plasticizer or the processing aid replaced with HOSO. And you can see from day 0 to day 15, the plaques looked virtually identical. There was some debris on it from the bedding material for the mouse, but you could really not see any indication of gnawing on this plaque. So looking at each of the individual materials and the loss of weight data, so this is natural rubber, again with degummed soybean oil, commodity soybean oil, high oleic soybean oil, and soybean oil grafted with styrene, and then the control, which had the naphthenic oil in it as a process oil. You can see that in general there wasn't much damage. But the damage that did occur, sort of bounced around the mean. In fact, some of the plaques actually gained weight because presumably either the debris that you saw previously was tried to be brushed off. We didn't wash the plaques, but there was also some thought that perhaps some water might have been absorbed by the plaques to lead to a weight gain. But all these data, all these 4 different types of formulation had statistically the same amount of damage, or lack of damage, I should say, in this case. Going to SBR, the case is very similar. The 4 different plaque formulations with and without the soybean oil derivatives. There was no statistical difference in the weight change. And again, very, very much, if very small amount of damage in general. EPDM, the 3rd formulation, as you can see, it's the same situation with the naphthenic oil or with HOSO. You still had very small amount of damage within the statistical variability of the data. PVC is a situation where we did see some damage both in the plaques with epoxidized soybean oil and in the plaques that did not have epoxidized soybean oil in them. These plaques suffered the most damage, much more weight loss than the other elastomers, but again, no statistically significant difference in weight change between the control and the ESO containing formulation. If we want to look at the damage assessment data, this is the subjective data where they were looking at 1 to 4 rating for how much of the area of the plaque was affected. And then you can see that these are the random plaque codes and the group numbers, and then the plaque IDs are listed in the center column. Again, very, very little damage, either with or without the soybean materials, except in the case of PVC, where the PVC control and the PVC with 20% ESO had, similar damage, again, within statistical control. If you look at the far right column, the graded plaques, the plaques that were graded 1, which was 0 to 25% affected. With the control, they had 4 total plaques. With the PVC with 20% ESO, 6 total plaques, and then so forth. So it damaged number 2, 3 total with the control, and only 1 total with the ESO containing material. Damage number 3, 2 total of the plaques, both with and without ESO, and then finally 4 total most damage. There's one plaque in the control and also one plaque in the PVC with ESO. So it's very, very similar results across all the four materials, all the four elastomers, and all the derivatives, soy derivatives, which were used. So in conclusion, we saw extensive gnawing only on one group of plaques, and those were the plaques made of PVC. But both the PVC control and the PVC with 20% ESO had the same amount of damage. And so we could not say that there was a preference derived by using soybean materials. So the other groups, the 10 rubber formulations, showed minimal gnawing damage of the plaques, either with or without the soy material. So the reason for this, we can speculate. Perhaps more resilient rubber simply wasn't, they weren't able to gnaw on it effectively, or you can see that the geometry of the plaques did not have an effect because the PVC and the elastomers had the same geometry there. They were the same thickness. They were 1/4 inch thick plaques, 3 by 3 inches. So the geometry between the PVC and the rubber was identical. But you could see that the elastomer, or the rubber formulations, did seem to be more resilient than the PVC material, which apparently was the difference in the rodent being able to actually gnaw enough on the plaque to create damage. So overall, the only damage difference we saw was between the 2 PVC groups and the 10 rubber groups. But there was not a statistically significant difference between the non-soy containing controls and the soy containing formulations in any of the 12 groups. I'd like to acknowledge a number of people that contributed to this study. The Akron Rubber Development Lab formulated and made the elastomeric plaques that were used. Integrated Laboratory Services did the rodent exposure testing. So they selected the rodent, they selected the container, and they also did the statistical analysis and did the evaluation, the subjective evaluation of the 1 to 4 rating of the plaques, as well as they did the loss of weight measurements. I want to thank Keith Cockerline, Brian Pierce, and Lisa Balbus of Smith Buckland for their support and suggestions, helping put together not only the study, but the paper that came out of this, which is available, as Chris had mentioned, and we're happy to send the link to anyone that's interested. The United Soybean Board funded this work, so we want to make sure that we acknowledge that and thank them. And thank you for your attention to this, the results of this study. And I'd be happy to field any questions or comments. And Chris, see anything?
Well, thank you, Rick. I'd like to invite everybody to type some questions into the chat box, and we'll ask those questions of Rick. But I have a few. First of all, when was the study published? How long ago? And what type of feedback have you received from the public, either industry or just common concerns that people have had?
The study, I believe, was published in 2021 during COVID. It was conducted a little bit before that. I think it was conducted in 2020, but it took a while to get everything together and published. As far as the concerns from the OEMs that had seen this study, they were, I think, relieved that they had this result. To them, it was a very good result, and allowed them to go forward and use these soy-based processing aids, as well as some other industrial applications like tires, etc. So from industry, I think it was very positive. We've had some people come to the booth where we have talked about this to them when we have a USB booth at certain trade shows. And some of the members of the public, especially those that have been unfortunate enough to have wiring damage are somewhat skeptical, I would say, although there's been wire damage by rodents, since there have been automobiles. And before that, there's electrical wire damage from rodents well before soy materials were used in wire coating formulations. So I think people really have to accept the fact that rodents just gnaw on things. And unfortunately, if they gnaw on something that's sensitive, they can cause some significant damage.
Well, particularly they enjoy PVC, it looks.
Yeah.
So people don't start blaming the PVC industry for this either.
Yeah.
Okay, just a few comments that have come up. First of all, we will provide the link for the publication. We have everybody that registered, so we will share that link and email that out to everybody after this webinar. The next comment, excellent work. Did you look at the use of HOSO, SBO, styrene as a plasticizer, and PVC rubber materials, as it seems that is more prone to not gnawing? I'm not sure if that's a question or a comment. So
Where?
you did. That was part of the study.
Yeah, the study included all those materials and the various elastomers. Was there a specific question about using those materials in another
Yeah,
rubber?
yeah, it just says as a plasticizer and PVC rubber materials, as it seems that it is more prone to gnawing. So,
Specifically PVC? Is that what?
yeah, PVC rubber materials. Well, that's PVC.
Yeah,
So
PVC,
maybe, yeah,
plasticized PVC. Well, we didn't look at the other materials. We were just looking at epoxidized soybean oil in that particular case, because that is so commonly used in PVC as a secondary plasticizer. Some of these other materials could conceivably be used there, but the epoxidized soybean oil has some real performance advantages in PVC. It reduces it scavenges HCl during processing and prevents it from degrading thermally. And it also gives some reduction in the phthalate content, and people are very concerned about phthalate use in general.
mhm.
So.
Okay, if we need to clarify that answer, please put it in the chat box or we'll get back to you on that. I wanted to move on to the next question. We are trying to make soy terrazzo as a new application where we are trying to replace petroleum epoxy with ESO and other soy resins. That's an excellent application. I'd like to know your thoughts about epoxy with rodents.
Yeah, I think in general, the epoxy is a very hard plastic, thermoset plastic. It's probably, I've seen rodents chew on wood. I've even seen damage to aluminum from rodents. So rodents are capable of gnawing on a number of materials, but I wouldn't expect the addition of the soybean oil or other epoxidized materials replacing petroleum-based epoxides. I wouldn't expect that to have an increase in the preference of gnawing. So I think, if a rodent is going to gnaw on something, whether it has soy in it or not, it may in fact gnaw on it, but epoxides are pretty hard, pretty durable. So, a terrazzo, I assume you're putting in some filler, maybe a rock filler or something into that. That would probably discourage the gnawing.
Mm-hmm. Yeah, that is a pretty tough resin, so that'd be a little more difficult for them as opposed to PVC. That's probably why you see such an effect on PVC, because it's one of the softer resins that you're working with. Right.
Right.
Okay, I just wanted to hold off another minute to see if anyone else has any other questions or comments. Oh, there's some in the Q&A box too. I think we captured all of them. If not, please let me know, or you can email us after the webinar. So I'm just going to hold off one more minute and see if I can get anything else from anybody. So again, we will send you a copy or a link for the published study afterwards. And then after USDA approval, we will also share the link on the YouTube channel. So at this time, I think that's it for questions, and that concludes our webinar. We greatly appreciate your attendance and hope that you found this informative and productive. And I really hope that you share this with industry and the general public. We really need to educate people in this area. So on behalf of the United Soybean Board, Smith Buckland and Omnitech International, we'd like to thank you for your interest. And we really encourage you to reach out to us if you have interest in USB funding or assistance in any technical or commercial development of soy-based products. You can also learn more by visiting our website, usesoyforthat.org, and there's overwhelming information there about various applications of soy-based products. Thank you for your time, and we look forward to seeing you again in our future Omnitech webinars.